Authorities are issuing ash cloud advisories. Air quality concerns are emerging as ash disperses over parts of western India. A volcanic eruption in Ethiopia has sent shockwaves across continents. A volcanic eruption in Ethiopia is now affecting India thousands of kilometers away. The Hayli Gubbi volcano has erupted for the first time since the last ice age. Ash clouds have crossed the Red Sea and Arabian Peninsula, reaching India and Pakistan. Flights are being cancelled and diverted, and aviation authorities are issuing ash cloud advisories. Air quality concerns are emerging as ash disperses over parts of western India. The Hayli Gubbi volcano sits in Ethiopia's Afar region, near the Eritrea border, around 800 kilometers from Addis Ababa. Witnesses described a terrifying blast, like a bomb suddenly exploding, followed by thick ash and smoke. The eruption column reached 14 to 15 kilometers, up to 45,000 feet, higher than the cruise altitude of most commercial aircraft. Satellite imagery from NASA and European agencies revealed the massive ash clouds spreading across the Red Sea. The ash drifted northeast across the Red Sea toward Yemen and Oman, guided by strong upper-level winds. Eventually, ash reached India and Pakistan, raising air quality concerns and disrupting long-haul flight routes. The eruption also released large amounts of sulfur dioxide, a gas that can alter atmospheric conditions and create hazy skies. The Toulouse Volcanic Ash Advisory Center quickly issued alerts to aviation authorities across multiple countries. Hayli Gubbi was silent for the entire Holocene epoch, 12,000 years without a single recorded eruption. Experts confirmed that Hayli Gubbi had no eruptions in recorded history, essentially considered inactive. Hayli Gubbi lies in the East African Rift Valley, one of Earth's most active geological regions, where tectonic plates are pulling apart. As these plates separate, magma rises, creating intense volcanic and seismic activity. Deep underground, magma and volcanic gases had been accumulating for thousands of years. A surge of fresh, hotter magma from deep within Earth's mantle heated the chamber, building massive pressure. When pressure exceeded the strength of the overlying rock, the volcano erupted explosively. Expanding volcanic gases propelled ash and debris high into the stratosphere. The eruption has blanketed several villages in the Afar region in thick volcanic ash. Aftara, one of the worst-hit villages, is now blanketed in ash. Homes, farmland, and grazing areas have all been impacted. For Afar's pastoralist communities, ash-covered grazing lands threaten their livestock, their primary source of survival. Tourists visiting the Danakil Desert found themselves stranded as the region was engulfed in ash. Authorities remain on high alert, monitoring ongoing volcanic activity in the region. Ethiopia has around 50 known volcanoes, many silent for thousands of years, yet still active deep beneath the surface. This eruption proves a critical point: dormant volcanoes can awaken unexpectedly. The local impact is severe, and the region remains alert as scientists watch for further activity. After the eruption, strong upper-level winds carried the ash cloud northeast, across the Red Sea toward the Arabian Peninsula. Upper tropospheric winds pushed the plume across the Red Sea, forming a massive cloud visible on satellite images. By Monday, the ash had moved over Yemen and Oman, continuing towards South Asia. By Monday night, November 24th, the ash cloud entered Indian airspace over Gujarat. The ash spread across Gujarat, Rajasthan, Haryana, Delhi NCR, Punjab, and Uttar Pradesh, tracked by the IMD. The ash cloud was at 35,000 to 45,000 feet, affecting aviation but not ground-level air quality. Pakistan issued alerts as the cloud entered its airspace. By November 26th, the ash cloud moved toward China, clearing Indian skies. A powerful volcanic eruption, thousands of kilometers away, unleashed immediate and widespread disruption across India's entire aviation network. This distant event quickly threatened flight operations and passenger travel across the subcontinent. Volcanic ash, composed of microscopic rock and glass particles, poses a severe threat to jet engines. Inside a jet engine, the extreme heat melts these particles, which then solidify into a glassy slag. This process can erode and clog turbine blades, potentially leading to total engine failure and sandblasting cockpit windows. In response to this critical threat, India's Directorate General of Civil Aviation, the DGCA, immediately issued a strict advisory. This directive mandated airlines to avoid ash zones, reroute flights, carry additional fuel, and report any encounters with ash to ensure safety. Major Indian airports, including Delhi IGI, Mumbai T2, and Cochin International, were significantly impacted. Airlines like Air India, IndiGo, Akasa Air, and SpiceJet faced numerous cancellations and diversions, disrupting thousands of travel plans. The ash cloud drifted across western India at cruising altitudes, specifically between 35,000 and 45,000 feet. This forced pilots to reroute flights by hundreds of miles, bending trajectories around the dangerous zones to circumvent the atmospheric hazard. This widespread disruption resulted in thousands of passengers being stranded across various airports. Airlines worked to mitigate the impact by providing accommodations and rebooking services, but the ripple effect of the volcanic ash spread across India's travel infrastructure. When news broke of volcanic ash from Russia's Sheveluk volcano reaching India, fears grew, especially in a pollution-hit Delhi. But the reality, as clarified by the IMD, is far more scientific than sensational. The India Meteorological Department confirmed the ash remained between 35,000 and 45,000 feet, specifically 10 to 14 kilometers high, far above the air you breathe at ground level. India's weather chief, Mrityunjay Mohapatra, clarified that the ash cloud had absolutely no impact on ground-level air quality or weather conditions in India. Delhi's air quality index hit a very poor 362 for reasons that had nothing to do with volcanic ash. Local pollution sources, including stubble burning, vehicular emissions, and industrial outputs, dominated the air. A winter inversion traps pollutants under a warm air lid, typically between 500 to 1,000 meters. The volcanic ash, at 45,000 feet above, physically couldn't enter this lower boundary layer. Experts noted that minor visibility effects aloft were possible for aviation, but these were negligible compared to India's severe ground-level pollution and high PM2.5 concentrations. In short, volcanic ash never reached the ground or impacted surface air quality. Delhi's significant pollution crisis was entirely local, driven by regional factors. Satellite imagery revealed a massive sulfur dioxide plume originating from the Hayli Gubbi eruption, drifting from Ethiopia across Arabia and into western India between November 23 and 25, 2025. Most of this sulfur dioxide remained at an altitude of approximately 2.5 kilometers, significantly above the typical breathing zone, thus posing no immediate threat to people in India. However, Oman experienced stronger effects as the plume descended, leading authorities to issue air quality advisories for its coastal and interior regions. The volcanic gases and aerosols injected into the atmosphere created unusually vivid and prolonged sunsets across India and Arabia, a phenomenon caused by atmospheric scattering. Despite its visual impact, the Hayli Gubbi eruption was not large enough to inject significant material into the stratosphere, meaning it had no measurable global climate cooling effect. This volcanic activity is intrinsically linked to the East African Rift, a major geological feature where the African tectonic plates are slowly pulling apart. As the East African Rift continues to evolve, further volcanic eruptions and geological activity remain a distinct possibility in the region. Using NASA, ESA, and VAC data, IMD tracked the ash cloud in real time. Satellites across the world provided continuous tracking, feeding data straight into India's monitoring network. Aviation regulators acted quickly. DGCA advisories ensured pilots avoided hazardous airspace. Clear public communication helped avoid panic and kept the situation under control. India doesn't face local volcanic threats, but distant eruptions can still affect its skies. Stronger cooperation with volcanic regions can improve early warnings and preparedness. Pilots, ATC, and ground teams need ongoing training to detect and handle volcanic ash events. Better public understanding of atmospheric science prevents confusion during such events. This event gives scientists rare, valuable data on how volcanic gases from East Africa travel to South Asia. A volcanic eruption in Ethiopia disrupted travel and commerce across continents in hours, proof of an interconnected world. Volcanoes dormant for thousands of years can reawaken, and hundreds of such giants lie across the globe. An Indonesian eruption could send ash toward India more directly, affecting aviation and possibly air quality. Climate shifts can alter pressure on volcanoes and impact their behavior, an area scientists are actively studying. India is far from major volcanoes, but global wind and travel networks link us to distant geological events. India must continue enhancing monitoring, cooperation, and emergency response to stay prepared. Scientists will continue watching the East African Rift, one of Earth's most active geological zones. Let's recap the key points from today's video. On November 23rd, Ethiopia's Hayli Gubbi volcano erupted for the first time in 12,000 years. For India, the biggest impact was on aviation. Dozens of flights were cancelled or diverted. The ash never reached the ground. India's pollution crisis is entirely local. Monitoring, communication, and coordination worked well. This eruption shows how connected our world is. An event in Ethiopia affected India within hours. Were you affected by cancellations? Did you notice anything unusual in the sky? Tell us in the comments. Thanks for watching. Stay safe, stay informed, and see you in the next one.